85 maximum rectangle. The question is given a row and columns, so we can field with the 0 and 1 and find the largest rectangle contains only 1 and return is 0. Okay, so we can treat like the row, right? First row, second row, and calculate stuff from the first row we will calculate, and then second row, third row we will use the global maximum to check it. So let me write the code first, then explain it better. Equal to the matrix length m is equal to matrix 0 length, and for this one is height, new m is column, smaller than an I++. Okay, so what's gonna do is if the matrix ij is equal to 1, so we can height j equal plus plus, not equal to 0. Okay, when this row finish, we have the result. And the return the result is the largest rectangle height, private int Okay, then we have something here is 0, right? So here's the Q. And also we also need a result. Smaller and equal than height length. Okay. Height I, while the stack is empty. Stock is not empty, so we need to and stack pick last. It's larger than curve. We need to update the result. If not, we just keep cat over last here. Okay, so also need this. This purpose is to pop the stack. It's equal to the current equal to the heights. Okay, so when we finish this, like last and int int left is equal to if the left, right, and if the stack is empty, so we should treat the left is equal to 0. If not, stack is left equal to the peak last plus 1. Int y is equal to the current I minus left, and the results should update here. Left times wide. Yep, I think it's no, not left. It should be height. Let's see. Okay, so oops. If I equal. Yep. And for the time complexity for this one, TC is n squared m. M space should be the n. Yeah, let's see. This one is should be as yeah. This is the idea about these problems, and it's very similar to the 84. If you finish the 84, it's very similar to this one. So we can we can try to figure out the problems. 84, this one. So you can see this idea, given an array of integer heights represent the hi and return the areas of this one. So we can use this to explain that. So we can use let me copy this one. You can see it's right. So I can take the example. So 2, if we put in we got the heights into the 2, right? Now we have the stack. So stack is to store the index of the previous one. So we can start from the beginning. It should be 0, 1, 2, 3, 4, 5, 6. So this one is for another leader to explain this. So for the current is equal to high, current here is 2. And current hair stack is not empty, so we will not go in this while loop. It will go into the offer last, so which means offer the I, it should be 1. And now we keep for loop, right? So current here I should be the 1 here, And 1 is we're going to, current cur is equal to 1 now. No, current cur is equal to, index is 1, so it's 1 now. So we check, right? Check previous 2 is larger than the 1, I mean the height. So, and also stack is not empty, so we need to calculate the previous one. So we have to, height is 2, stack is empty, so it starts from the 0. Now we have the wide, right? So wide is I minus left minus 0 is equal to 1. So 1 is 1 times the previous height is 2. So this is calculate the stack height. Not current here now. Current it should be in the nest to calculate. Okay, this one is finished, right? So current result is should be 2, so it makes sense. This one is already popped out. So stack is empty now. We need to offer the 1 here inside. So 1. So we 1 put inside. For here it should be the I should be 2. So 2 should be 5. So we gotta be her height is 5. So we put in the 5. Put in the 5. Put in the 5 is the index is 2. Because previous is not larger than the 5, so we just go inside here. And now we keep going. Current here is equal to the 3 now. We got 6. 6, current here is 6. And 6, previous 5 is not larger than 6, so we don't do anything. So we just keep putting the index in the stack. And now we come in, go to the 4. Okay, 4, right? Okay, so 4 here. 4 current is 2. Okay, so we pick up the 6. 6 is larger than the current now. Large curve, right? So we need to go to inside here. So current is the previous 6 is larger than the 2 now. Previous high is the 6. Stack is the not empty. So we pull out this one. It's not empty. So we got the pick the last is 2 plus 1 is equal to 3. So the I current is 4 minus 3 is equal to 1. And the 1 times 6 is 1 times 6 is equal to 6. So current now the maximum update. And now we keep tracking, right? So keep the stack is not empty, so we still have the 5 here. So we keep looking for this one. So 5 is also larger than the 2. So we will keep going this way. Height. For the last. So we just put out this one. So left pickup is the 1 plus 1 is equal to 2. So current I is 4 minus 2 is equal to the 2. So 2 times 5 is equal to the 10. So this is maximum. So we pull out the 5. So current here is 2, right? So we just calculate the previous one. So for here, for here, for here, for here. And at the last, when the curve is, it will become the 0. So it will calculate all of them. Did I see? It's equal to 10. Now we just keep doing, right? So current stack is empty. And also high is the, now we keep going to the 2 is larger equal than 2. We also need to pull out this one, 2, and current now step is empty now. So we have to 0 equal to 0. 0 is equal to 0, right? 4 minus 0 is equal to 4. So 1, 2, 3, 4. 4 times 2 is equal to 8. Our current now stay empty. So we keep put the current index is 4 inside. 4 inside. Okay, now we keep moving here. The current height is going 5 now. The last one. 5 is 3, so we come here 3. So we can check the previous 2 is larger than the current here, right? 2, 3. We definitely will go in this way. So 2, 3. 2 is smaller than 3. We will not go inside. So it will go to put in the 5 inside. Okay, so this one, why we need equal here, this is very important. So which means we come into the 6. And the 6, right? 6 is equal to the height length, so the current here is 0. So all of them, like a 3 is larger than the 0. So we have to pull it out. 3 is larger than the 0. Current is 3, and it's empty, right? So we got into the 4 plus 1 is equal to 5. So y is 6 plus 5 is equal to 1. So current now is 1 times the 3. Okay, so we need 3. So update the result, right? And keep y because stack is not empty. So current here is coming to the 2 minus 0. Then we come into the 2, right? Coming here 2, empty. It's empty, so we start from the 0. So start from the 0 here. And start from 0, so which coming for the 0 times 0, current 6. Current is I is equal to, current is 6. Left is current 2 larger than the this one 0. So height is should be 2. Stack is empty now. Stack is empty, so left is 0. I is equal to 6 minus left is 0. So it's equal to the equal to 6, right? And 6 height is 2 times 2, 6. It should be 12. It's not the. It's a no. It's wrong here somewhere. Take the last. Curve is 0, right? I mean, this 2. larger than 0. Five larger than this, and 6 larger than this, and 2 larger than this. Okay, so this actually, sorry for this one, this 2 is already not exist now. Why it happened here? This one is not exist. Okay, but let's use the debug to go follow the, that would be better to let me submit. It should be work. Okay, so we start from the results, right? So curve is 2. So we put in the stack 0 inside. We have to check this one. Current height is 2, and stack is empty, so left is 0. Then int wide is I minus left is equal to 1. 1 times the 2 is equal to 2. Okay, the first run is okay. Now we keep going. Current here, stack is empty, so it will not, and put the I in this one inside, and then this will not. Its worker height is equal to the. You can see, current height is 5. Yeah, 5. It will not, because the previous one is equal to 1 is smaller than curve, so keep adding the 2. It's keep going to side. It's current is 6. 6, no, it will not doing this thing. It will keep moving. Okay, so we come and go to the 4 here, or the 2 here. Okay. Current result, current high is 2, so we need to pull out the previous one. Height is 6, and the stack is not empty, so the left will be the two plus 1 is gone 3. And we pick up the maximum result is 1 times 6 is 6, right? And keep checking, the 5 is still larger than the this one. Is will go inside and pick up the, it should be the 1 plus 2. So current is the 4. 4 minus the 2 is equal to 2. 2 times is 10. Yep. And now we come into the 1. Right? It will not come in here. It will left 1 and 4. 1 and 4. Okay, so we come in, going to the last one is the 3, right? 3 is 3 is larger than the 0, not 3. It will not go inside here. It will keep going to the, yeah. And then now we come in for the last one here. Curve is 0. So the last current pickup, current height is what? Current height is 3. That is not empty, so we pick up the 4 plus 1 is 5. 5, right? The width should be 1, and it will be the 5. And then we come in for here, so that is not empty and still larger than that, is equal to the 4. 4 index should be the 2. Yeah, 2 stack is plus 1. 2 pick up the 1 is 2. 2. Okay, pick up 1 is 2, so 6 pick up the 2 is equal to 4. Sorry, I'll read this again. Equal to the 4, right? 4 is times the is what? How much now? Okay, it's close now. It's the width it will be the 4. 4 times the height 2 is equal to the 8. Then we have the last one is 1. 1 definitely larger than this. Oops. Yeah. Current 1 is here. Left is empty now, it should be start from here. And then 1, right? Start from 0, so which means the 6 minus 0, it will be 6. Yeah, this is the, then return the result. It is finished. It's very tricky, but the logic is similar. If you solve these problems, you can solve this problem. Yeah, thank you.